Hello everyone, welcome to IIT's Gate classes. So in today's video session, we are going to see the electronics and communication engineering solution for your network theory for Gate 2023. So in Gate 2023 from network theory for electronics and communication, the total marks of question was 6, out of which 1 mark question were 4 and 2 marks question were 1. So before starting the video, let me remind you that if you are visiting the channel for the first time, please do subscribe our channel for more such content. And if you like the video, then please press the thumbs up button along with sharing this video with your friends. So the first question that we have over here is a series RLC circuit has a quality factor of 1000. So quality factor given is 1000 at a center frequency means resonance frequency of 10 to the power 6 radian per second. The possible value of R, L and C. So we know omega naught is actually 1 by under root of LC radian per second. Now if you put the value of L and C in option A, B, C and D, you can see you will get omega is equal to 10 to the power 6 radian per second, because here it is all the values of inductance is your 1 microhenry and capacitance is 1 microfarad. So that will be 10 to the power minus 6 into 10 to the power minus 6. So this will be 10 to the power 6 radian per second. So all the options are satisfying this value of omega naught. Now, here it is given that this is a series RLC circuit and quality factor is 1000. So, quality factor for a series RLC circuit is given by omega naught L by R. So, now if I put the value of quality factor, that is 1000, is equal to omega naught value is 10 to the power 6, L value it is 1 microhenry, so 10 to the power minus 6 divided by R. The value of R that I get is 1 by 1000 ohm, which is equal to 0.001 ohm. So you can see option D is your correct answer. So the next question that we have is, in the circuit shown below, the current I flowing through 200 ohm resistor is. So what is the current I flowing through this 200 ohm resistor? You can see over here all the current sources are given in milliamp and resistance in kilo ohm. Okay, so note this, except this resistance which is given in 200 ohm. So let me convert it into kilo ohm. So that will be 0.2 kilo ohm. So now you can see I can do what? I can convert this practical current source to practical voltage source, this one, and this current source. Okay, these two practical current sources, I can convert it to practical voltage sources. If I do that and redraw the diagram, so this will be, so this is 2 kilo ohm, this is your 2 volt, you can see this is also 2 kilo ohm, and 1 milliampere is flowing in this direction. So obviously the direction of the voltage source, polarity of the voltage source, it will be like this. Over here, this is 1 milliampere. So this will be 1 kilo ohm, and the direction, polarity of the voltage source, it will be like this. So this is 1 volt and this is 0.2. Okay. So now simply what I am going to do, I have to find this current I. Okay, I have to find this current I. So basically, what I am going to do, I am going to apply nodal equation at this point. Let the nodal voltage be V at this point. So if I apply nodal analysis. So this will be V minus 2 by 2K. As there are two branches, so what I am going to do, directly multiply it with 2, and this will be V minus of minus 1, because this we have, divided by this two resistance are in series. So this will be 1.2 kilo ohm equal to 0. So this 2 and 2 get cancelled. So this will be V minus 2 plus V plus 1 divided by 1.2 equal to 0. So I can write this as 2 minus V equal to V plus 1 divided by 1.2. Let me take it over this side. So this will be 2.4 minus 1.2 V is equal to V plus 1. So if I solve this, we will be getting 2.2 V is equal to 1.4, or V is equal to 14 by 22. Okay, V is equal to 14 by 22. So this current I will be what? I is equal to V minus of minus 1 divided by 1.2, because these two resistance are in series. So V plus 1 divided by 1.2. So that will be 14 by 22 plus 1 divided by 1.2. So this will be 36 by 22 divided by 12 divided by 10. So this will be 36 into 10 divided by 22 into 12. So 12 threes are. So this is 511. So 15 by 11. So I think this will be 1 point. So 4, 1.3. So 33, 7. So 1.36 volt. Okay, approximately your answer will be for this question 1.36 volt. Okay, sorry, 1.36 milliampere. I'm very sorry, because this is your current value, as the resistance is already in your kilo ohm. So this will be 1.36 milliampere. So in the next question that we have, for a two-port network shown below, the Y parameter is given as this. The value of the load impedance ZL in ohm for maximum power transfer will be. So we know in a circuit, maximum power transfer occurs when your load resistance is actually equal to your Thevenin, your load impedance is actually equal to your Thevenin impedance. Okay, so if this is my circuit, for maximum power to transfer from source to load side, your ZL should be equal to your Thevenin resistance of the circuit, Thevenin impedance of the circuit. So let us try to find out this Thevenin impedance. So ZTH, if I want to calculate, see, let me mark this. So let this be I1, this be I2, this be V1, and this be V2. So Thevenin impedance, if you have to find, that is ZTH. So that will be equal to V2 by I2. Is this correct? Is this correct? No, this is not correct. Here I have to add one more point, that Thevenin resistance is actually equal to V2 by I2 when all the independent sources are 0. Independent source is this 120 volt. As this is a voltage source, so what I am going to do, your voltage source will be short. If this was a current source, I would have opened this circuit from here. Okay. So now let us try to find out ZTH. Okay. So one by one, let me write the equation. I am erasing over here this part. So we know if we expand this Y parameter, so it will be I1 is equal to 2 by 100 V1 minus 1 by 100 V2. Equation 1. I2 is equal to what? It is equal to minus 1 by 100 V1 plus 4 by 3 V2. Equation 2. Now, One more thing, we are trying to find out ZTH. So independent sources is 0. So I am shorting this voltage source. So the moment I short this, this will now become 0 volt. So one more KVL I can apply in this loop. Okay, in this loop I can apply, means this one, starting from here in this loop. So that will be what? So you can see 10I1 plus V1 equal to 0. Okay, I can write this. Or what I can do basically, I can write I1 is equal to minus V1 by 10. Equation 4. Okay, equation 4. Oh, sorry, let this be equation 3. So let me substitute equation 3 in equation 1. If I do that, so this will be minus V by 10 is equal to 2 by 100 V1 minus 1 by 100 V2. Okay. So let us solve this. So 1 0 will get cancelled. So this will be minus 10. Sorry, this is V1. So 10 V1 is equal to 2 V1 minus V2. So V2 is equal to 12 V1. So V1 is equal to V2 by 12. Let this be equation 4. Now if this equation 4 I substitute in equation 2, what will happen? You see is, so I2 is equal to what I have, minus 1 by 100 V1. So V1 is V2 by 12 plus 4 by 3. Okay, so I think I have missed 100 over here. So this was into 1 by 100 V2. Okay, plus 4 by 3 into 1 by 100 V2. Okay, so now this expression, this whole expression is in term of V2 and I2. So what I will be doing, so let me take this 100 over here. So this will be 100 I2 is equal to minus V2 by 12 plus 4 by 3 V2. So multiplying LHS and RHS by 12, so this will be 1200 I2 is equal to minus V2 plus 16 V2. So this will be 15 V2 is equal to 1200 I2. So V2 by I2 is equal to 1200 by 15. So this will be what? If I divide numerator and denominator by 5, so this will be 240, this is 3, so this will be 80. So this comes out to be 80 ohm. Okay, so your ZTH comes out to be 80 ohm. So I have already shown that when your ZTH is equal to ZL, at that time maximum power transfer will happen. So the answer to this question will be 80 ohm. So the next question that we have over here is what? In the circuit shown below, the switch S was closed for a long time. If the switch is opened at t equal to 0, the maximum magnitude of the voltage VR in volt is. So basically this is a first order transient LR circuit, RL circuit. So at t equal to 0 minus, we know at steady state inductor is basically what? It is your short circuit. So if we do that, redraw the circuit. So this will be 2 volt. There is this switch connected. So switch is connected. So we have 1 ohm over here. This is 2 ohm and inductor is short circuited. So what is your IL0 minus? So you can see basically as this is short circuit, so 2 ohm will also be shorted out. So basically IL0 minus, if I apply KVL in this path, so from here also IL0 minus will flow because this 2 ohm as it is connected to this short circuit, so this will also get short. So IL0 minus will be equal to 2 divided by 1, which is equal to 2 ampere. So now at t equal to 0 plus, when this switch is open, my circuit, it will become like this. So remember this, that the direction at means there is no instantaneous change in current in your inductor. So I can replace the inductor with an equivalent current source and the direction of the current will be the direction of the current source. So now you can see that this is polarity of VR is given. So this is plus minus VR and this is 2 ampere. Now you have been asked what is the maximum magnitude of the voltage VR. So you can see when at t equal to infinite, this current will be what? Inductor will once again become, it will become short. So due to that current will become zero. Why? Because this is your source free circuit. Source free circuit. So there will be no current. So current will start decreasing the moment this switch is open. So your maximum value of voltage VR will be at t equal to 0. So that will be what? You can see VR comes out to be 2. So value of this is 2 ohm. So this will be 2 into 2 ohm into minus 2 ampere. Why? You can see the polarity is from minus to plus and current here is flowing from minus to plus. Okay. So this comes out to be minus 4 volt. Now pay attention, if you mark minus 4 volt over here, then your answer will be wrong. Okay, your answer will be wrong because here it is asked the maximum magnitude. Magnitude is asked. So if magnitude is asked, so then it will be minus 4 volt mod. So that will be 4 volt. So your answer is plus 4 volt over here. Okay. So the next question asked over here is the switch S1 was closed and S2 was open for a long time at t equal to 0. The switch S1 is opened and S2 is closed simultaneously. The value of IC0 plus in ampere. So what is IC0 plus in ampere? So capacitor has this property that it doesn't allow sudden changes in the voltage. It allows sudden changes in the current, but it doesn't allow sudden changes in the voltage. Whereas in your inductor, there can be sudden changes in the voltage, but current cannot change instantly. Okay. So now let us draw the circuit at t equal to 0 minus. So at t equal to 0 minus, if I draw the rough circuit, so this will be, I have 1 ampere. Capacitor acts as your open circuit. Okay. At steady state. And this switch is closed. S1 is closed. And S2 is what? S2 is open. And inductor will be acting as short at your steady state. So I have this 25 ohm. Here I have 100 ohm. This is your IL0 minus. This is your VC0 minus. So you can see IL0 minus, I can apply current division rule. So IL0 minus will be equal to 1 into 25 divided by 25 plus 100, that is 125. So this will be 1 by 5, that means 0.2. 0.2 volt. So IL0 minus is 0.2 volt. So that means what? VC0 minus will be zero point 0.2 into 100. So that is 20 volt. Okay. So we have this. Now at t equal to 0 plus, let me redraw the circuit. So S1 will open. So I will not draw this. I will replace the capacitor with an equivalent ideal voltage source. So the polarity will be the same, plus minus like this. This is 20 volt and this switch has been closed. So 100 ohm is going to short out and your inductor is going to be replaced with an ideal current source having the polarity as before. So this is 25 ohm. Okay, 25 ohm. And this value is what? Sorry, IL0 minus I have written 0.2 volt. So this is ampere. So this is 0.2 ampere. Okay, and this is 25. So you can see this 20 volt and 20. So basically I have been asked what is this IC. Okay, IC. So simply what you can see, this 20 volt is in parallel. That means over here also I have 20 volt, over here also I have 20 volt. So if this is 20 volt, so current flowing through this branch will be what? 20 by 25. So that is 4 by 5 or 0.8. So 0.8 current is flowing in this direction, 0.2 in this direction. That means what? If I apply KCL in this node, so from here 1 ampere current is flowing, but look at the direction of IC. It is actually opposite to what your conventional current is flowing. So that means IC is equal to what? It is equal to minus 1 ampere. Okay. So always note the direction of current. So with this, we end this session. If you like this video, please press the thumbs up button and share this video with your friend. And if you are visiting the channel for first time, please subscribe the channel. Thank you.